This invisible cube here is meant to represent the volume of neon, the volume that the ideal gas neon occupies. The green dots represent neon atoms, and the orange arrows meant to represent the direction and speed of the neon particles. Because this gas behaves ideally, the molecules, the atoms are far apart from one another in no organized fashion. They are moving in straight lines until they either hit the sides of the container or another particle in there. And they're moving randomly with respect to one another. This gas neon here, there are 4 measurable quantities about a gas we can talk about. The amount of gas, the pressure of the gas, the temperature of the gas, and the volume of the gas. In this particular question, we know 3 of the unknown quantities. Now, this quantity here, amount, the question is looking for the grams of what is present, the grams of neon gas that are in this cube right here. We want to start our scaffold so that way the unit we're trying to discover is in the numerator on top. Let's look at the ideal gas constant. Here are 2 versions of writing the ideal gas constant that shows the relationship between the 4 measurable quantities. 0.0821 liters times ATM divided by moles times Kelvin, or the flip, moles times Kelvin divided by 0.0821 liters times ATM. Notice that whatever is on the top is now on the bottom. We go down here. Neither of these contain the unit grams. We want to start with grams on top. This is going to be useful because it has pressure, temperature, and volume, but it does not contain grams. Dun, 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 dun. The periodic table contains very much a chain link unit atomic mass. And the atomic masses that are taken off the periodic table always and every time have the units grams divided by moles. If we look up the atomic mass of neon, it's about 20.2 grams per mole. Let's start with that. Grams on top. And this number is the atomic mass of neon off the periodic table because that's the particular gas we're talking about. We need to cancel out moles. We need to choose the version of the ideal gas constant that would cancel out moles appropriately. Since moles is on the bottom here, we need moles on the top here. Which of these versions should we place in our scaffold next? As a brave knight in the documentary The Last Crusade, Indiana Jones and the Last Crusade once said, choose wisely. Tick, tock, tick, tock, tick, tock, tick. This version or arrangement of the ideal gas constant cancels out moles. Now we need to cancel out temperature, liters, ATM. Temperature first. Let's put this on the bottom. 250 Kelvin, because that top cancels out the bottom. The volume to cancel out, 2.75 liters. Now our liters cancel. Finally, our pressure needs to go up here, 0.98 ATM. Every unit is canceled out except for the unit we're looking for, grams. We had to utilize two resources that were not given to us in the problem. The periodic table we started with because it contains the unit grams about this particular gas, neon. The atomic mass of neon, 20.2 grams divided by moles. The ideal gas constant, we use the appropriate one to make a unit cancel. Now that everything is canceled out except for grams, we can pick up our calculator and multiply and divide. Thank you.